episode with the queries that you have asked. Okay. Yeah. So let's begin, and we shall start with the queries that have been asked on uh, Google form, and then we will take up your live comments. All right. So I hope my voice is properly audible to all of you. So let me just share my screen. So before we go to the Google form, there are a couple of questions that have been asked on email. So I'll just take them because they were asked uh, prior to the Google form questions. So I'll just take them. So these questions are from Mr. Tosh Agrawal. He is from Raipur and he is a practicing consultant. And he has asked a couple of questions. So let me just answer them to begin with. Okay, good. So, and then he has shared some supporting images also. So his first question is vertical joint allowed in pore strip at intersection of two slabs. So vertical joint allowed in pore strip. So I think what he's trying to say or ask rather, suppose I have this slab panel. Just a minute. Yeah. So in plan, let's say this is my slab panel one, and then I have another slab panel. Let's call it slab panel two, and in between these two slab panels, let's say this is my pore strip. Now we all know why we may be requiring pore strip, because let's say we want to avoid differential settlement, or we want to avoid temperature stresses or any other issue like that, because of which we are providing this pore strip. So pore strip means that the sequence of casting, this will be, these castings will take place at a different time, and the pore strip will be cast at a later time. Okay, that is the meaning of pore strip, that we are going to leave this space empty and going to cast it later. So his question is vertical joint allowed in pore strip at intersection of two slabs? So I'm not sure what exactly he is meaning by the question. Vertical joint allowed in pore strip at intersection of two slabs. Maybe saying, let's say this is my slab in section, and then this was another slab S2 in section. So vertical joint, I think by vertical joint he means that, let's say this is my pore strip, is a joint like this allowed in the pore strip, vertical. So I would say, if that is the question, if I properly understood, my answer will be that generally, not only in pore strips but otherwise also, we try and avoid having a vertical joint in slabs. So usually we will have it at a slant, and usually the slant is done like this. So I mean, see, technically, I would like to do this pore strip in one cast, but let's say due to some unavoidable reasons, you are not able to cast it in one go. Then instead of leaving a vertical joint, leave a joint like this, slanted at, let's say, around 45 degrees. So because of this slope, the shear transfer will be more effective. Shear transfer between the old concrete and the new concrete in the pore strip, sorry, will be more effective. And instead of leaving a vertical joint, this type of a joint at certain angle is preferred. Okay, so I hope this is what you wanted to ask. Technically, I would want to avoid any joint in the pore strip, because the idea of pore strip is to do it in one go. But let's say due to some unavoidable circumstances, you had to provide it, then do it this way. All right. His next question is, and he has written it on a piece of paper and then shared it. So I'll just put that image. I hope this question is visible. Shear stirrups in raft for one-way shear will resist two-way shear also. How one-way shear reinforcement distribution on raft is like this in both direction. Okay. So see, first of all, I think this question regarding the punching reinforcement for one-way shear and two-way shear has been asked by engineer Vineet Kumar also, who is joining us from Patna. So what I will do is I'll just copy his questions also, because they were both of the queries were similar in nature. So let me just paste it here and let us try to address them together. So this text format, this question has been asked by engineer Vineet Kumar from Patna, and this image that I am sharing has been asked by engineer Tosh Agrawal from Raipur. So let's see what they want to ask. Okay, so his question is related to shear stirrups in raft for one-way shear. Will it resist two-way shear also? Okay, and then let's see what are these questions. How is punching shear reinforcement designed if drops are not provided in raft foundation? What is a better arrangement for punching shear reinforcement, orthogonal or radial? If punching reinforcement is provided orthogonally, can it also serve as reinforcement for one-way shear? Is it necessary to provide one-way shear reinforcement in addition to two-way shear reinforcement? So see, first of all, don't get confused with a separate behavior for one-way shear and separate behavior for two-way shear. They are just shear in the periphery. Where will where will you have, let's say this is my column, and if you check the stresses, okay, if you are checking the stress contours, if your stress contours are like this, let's say because of a presence of beam, because of presence of a stiff element, call it a beam, your shear contours will be usually like this, isn't it? So this type of a shear contour or this type of a shear behavior where the stresses do not form a closed perimeter, but the stress distribution is like this, we usually call it as a we usually call it as the one-way shear. Okay, why are we calling it as a one-way shear? Because it's not forming a closed perimeter, rather these shear contours are like this, uh, in a particular direction. So we will call this as a one-way shear contour, or this behavior we will call it as a one-way shear. Now suppose you had a case where you had a column and you did not have any beam. Now in this case what will happen, that the shear, because of an absence of any stiff element like a beam, what will happen, the shear contours will be all around and they will form a closed perimeter around the column. In this case we will call it as a two-way shear. So first of all, don't get confused with one-way shear, two-way shear. Are they any different? No, they will depend on the type of structural configuration that you have, and just for our comfort, we give it two different terms. Okay, so one-way shear and two-way shear. Okay, now how to calculate the punching reinforcement for raft? How is punching shear reinforcement designed if drops are not provided? So calculation for punching shear we have explained in our earlier courses. In some of our courses we have discussed this issue. So calculations is simple. You first find out what is the total shear acting on this column. Let's say this column was part of a raft. So first of all, first you need to figure out, let's say this was a raft and this column was part of a raft. So first thing is to find out the total shear acting, that you can find out from your safe output. Let's say if you have made a safe model, you can uh, find out the shear acting from your safe output, or let's say you can use the tributary area method to uh, approximately find how much shear will be acting. Once you get this, then you say that this will be taken by Vs plus Vc. Now there are certain rules when you have to provide uh, punching reinforcement, when you have to revise the slab thickness. Those rules are given in IS 456. clause number are, I think, section number 30, where flat slabs are given. You can refer to those provisions. We have covered these things in detail in our flat slab design course. So the general rule says that when your VU upon VC is more than 1.5, that means whatever shear concrete can take, if VU exceeds it by more than 1.5, then you are not allowed to provide punching reinforcement. You are required to revise the slab thickness. It does not talk in terms of shear, it talks in terms of stress levels. So if the shear stress exceeds the concrete stress capacity or concrete capacity by more than 1.5, then revise the slab thickness or raft thickness. No amount of punching reinforcement will be sufficient. If your ratio of tau v upon tau c, let's say, is between 1.5 and 1, then you can provide punching reinforcement in case you don't want to increase the slab thickness or raft thickness. And of course, when this ratio is less than 1, you don't need to worry about any punching reinforcement because concrete itself is able to take all these shear stresses. So from, let's say, my tau v upon tau c ratio was between 1 and 1.5, and I don't want to increase my raft or slab thickness, so I decide to provide punching reinforcement. So first I'll calculate Vs. How do I calculate Vs? So I'll say it will be Pu minus Vc. Now in this, Vc will be what? So we will take the concrete capacity in punching shear. That is how much? So that is what? 0.25 under root FCK. Is that correct? Tau c for punching shear. Sorry, yeah, tau c for punching, I think. Yeah. Now our code IS 456, the same section 30 that I was referring to, 30 or 31, whatever, flat slab section. When you read that, it does not allow you to take the tau c till this level. It tells you that because you are providing punching reinforcement, you are only allowed to take zero point 0.5 tau c. So that means this value needs to be multiplied by zero point 0.5. So from here you can calculate VC. How? So you have the zero point 0.5. This you multiply by the critical punching perimeter, which is at d by 2, and then you find out VC. Once you get the VC, you do VU minus VC to get VS, and from this, then you find out the. So once you have the VS, these are the this is the shear steel that is required to take care of the punching. So now things become easy. Let's say this is my column, and the critical perimeter was d by 2. So something like this. Okay. And then what do you do? So you have the VS. You can find out 0.87 FY ASV. So from here you find out the VS. Sorry, you have the VS. From here you find out the area of steel that can take this much punching, or area of steel that can take this uh, Vs. All right. So from here you find out the area of steel. Now this area of steel, we can distribute it as bars, single bars in plan view like this. You can proportionately distribute it along the d by 2 closed perimeter. So something like this. And now the code asks you to take it till a distance when your tau v value becomes half. Okay. So code wants you to take this or continue this punching reinforcement till a distance, so that I'll just read out the exact thing because I'm slightly forgetting it. So let me just read out. Section is 30 point something, flat slab. I'll just take you to the clause. Acha, section is 31 point something because 31 is the section for flat slabs. But where is it? Shear in flat slab 31.6. Okay, good. 31.6.3.2. Yeah, so this is the clause. I've just copied it. So when the shear stress at critical section exceeds this, shear stress shall be provided up to a section where shear stress does not exceed zero point 0.5 tau c. Okay, so you have to extend this till a distance when your tau v upon tau c becomes less than equal to zero point 0.5. Till that extent, you have to provide this punching reinforcement, and we will try and provide punching reinforcement because because punching acts in a closed perimeter. We provide it like this as a links all around till the distance when your tau v upon tau c becomes less than zero point 0.5. So this is one way of providing the punching reinforcement. The other way of providing punching reinforcement is like a beam. So in that, what we do, let's say this is my column and the critical perimeter all around was d by 2. All these things we have discussed in detail in our flat slab online course, but here because of time constraint, I'm not able to take it up fully. One of the other ways is to provide an arrangement like this. So this is something like a beam arrangement. Of course, this is the plan we are showing, and just like a beam, we will provide stirrups. Okay, are you able to understand? What are these green bars? These green bars are bars of the flat slab or raft, whatever. And then these black things are stirrups that we are providing, uh, like this. So this is one of the other arrangement that is possible when it comes to shear reinforcement calculation. Okay. So now the question is, which is better, if punching reinforcement orthogonal or radial? So I'm not sure which arrangement you are calling as orthogonal, which is the arrangement you're calling it as radial. But in my opinion, this is the better arrangement when it comes to punching shear reinforcement. Why so? Because in this beam-like arrangement, we are missing out on these points, which are sort of not getting any reinforcement for. So we are missing out on these corners. Okay. In this arrangement where we are providing links all around, we are not missing out on those four corners. So in my view, this arrangement is the better arrangement. Then his next question was, is it necessary to provide one-way shear reinforcement in addition to two-way shear reinforcement? So see, you do not take it as one-way or two-way. What you can do is, let's say this is your column. Okay. Now you have provided links over here. And this question will also answer what Mr. Tosh was asking. Now you go to D distance, suppose. Now at D distance, what you do? Very simple. You just check the shear stress, or just check the VU value in this region. Okay. So you may be checking it in contour, or you may be checking it in stress format. You just check it. See if that VU, or if you are checking it in terms of tau V, see if it is exceeding VC. Yes or no? If it is exceeding VC, then you need to think about providing reinforcement. If it is not exceeding VC, then that's enough. You don't need anything. See, one thing, this punching reinforcement was required technically at D by 2. Now we are told by the code to extend it till it becomes zero point 0.5 tau c. That's why we have to extend. Technically, it was required at this critical section only, but then we are required to extend it till a certain distance. Okay. So what you do is that suppose you are getting confused whether it has to be added to one-way shear reinforcement. Yes, no. You just check. Don't worry about one-way, two-way. Just check the shear values over here. So in safe, let's say if this was local axis 1, this was local axis 2. So on this line, you will be checking the V23 shear, and on this edge, you will be checking the V13 shear. So just check those shear values, see if that shear value is exceeding tau c or that shear value is exceeding Vc. If it is exceeding, provide reinforcement. If it is not, don't do anything. Clear? Okay. Okay. And then Mr. Tosh is asking. So these were Mr. Vineet's questions. Now let's see what Mr. Tosh was asking over here. Shear reinforcement distribution raft is like this. I think one-way shear, two-way shear we have answered. One-way shear reinforcement distribution raft is like this. Yeah, so correct. So for example, how it has to be distributed. So for example, this is my column, and suppose on this edge you wanted to provide one-way shear reinforcement. So what will happen? These will be your legs. So this becomes your ASV. Understood? Then when you distribute it, so suppose this was my local axis 1, this was my local axis 2, safe local axis. Let's say you are using safe software. So this is for V13 shear, sorry, V23 shear that I am checking. So for V23 shear, when you find out, this is your ASV, and then you are going to distribute it. So next set of bars come like this, let's say. So this becomes your SV. Are we clear? So as you know, for VU, sorry, for stirrups, we require what? Two things: 0.87 Fy ASV into D upon SV, isn't it? So for V23 shear, these become my ASV, and then when I provide the next set of stirrups, these become my SV. Is that clear? Okay, good. So yeah, I hope this is clear. Is it necessary? No. So this is done. And I think Mr. Tosh has shared one image. Let me just see if that I can provide my. Okay, so he has put up this image. So what is happening in this image? So you see a lot of links. So now suppose this was being checked for, suppose it was being checked for V13 shear. So what will happen? These individual bars will become my ASV, and when they are distributed in this direction, they will become my SVs. Got it? Okay. Okay. So these were the questions related to punching shear reinforcement that were asked. So we clubbed two set of questions. There is another question asked by Mr. Tosh Agrawal related to shear enhancement factor in beams. So his question is, please elaborate about the shear enhancement factor, when to consider it. So if you refer to the IS code, and I have just kept it open over here. Let me just try to open it. So when you are checking shear, when the section at which you are checking shear is very close to the support, then you are allowed to enhance the shear strength by this shear enhancement factor, which is given as this to, let me just go to the clause first. Yeah. So the enhancement Enhance shear strength of sections close to support. So the enhancement of shear strength may be taken into account at in the design of sections near a support. So let's say this was my face of support, and the section at which I am considering my shear is quite close to the face of support. Then you can enhance, and it is closer than 2D. So if your AB is closer than 2D, then you can enhance the shear strength, and that enhancement factor 2D upon AB, you can multiply it to tau C. Okay, and then you can find out the shear reinforcement accordingly. So suppose we do the uh, Vs is equal to Vu minus Vc. So now the Vu has been enhanced because we are multiplying the tau c by this 2d upon AB. So you can do this way, and then you can find out the reinforcement. So they have given the reinforcement calculation. This is the same formula, just the difference is that tau v, now we are subtracting, instead of subtracting tau c, we are subtracting 2d upon av into tau c because we are enhancing the concrete shear strength. Otherwise the formula is the same, and this reinforcement will be provided in the av zone. So the code says that you provide this reinforcement in the middle three quarters of av. That means the middle 3/8 of av you provide this reinforcement. If av is less than d, then instead of providing vertical reinforcement, you provide horizontal shear reinforcement. If you don't want to go into this, you go with the simplified approach, where what you do, that you just check your shear at distance d from face of support, and then accordingly compare it with tau c from table 19. So you don't do any enhancement, but then you check the shear at d distance from face of support. Is that clear? Okay, so this is the concept for shear enhancement. Okay, then what do we have? Let's then go to next questions. So these were the two questions that were asked. Let me now take you to next set of questions. So just a minute. Okay, so Mr. Narayan Muduli, he's joining us from Bhubaneswar. He's asking how to model spring stiffness for pile foundation in StatPro. This question we had answered before also in our earlier Ask AuxEn Anything session. So you need to find out the load settlement curve. You need to have the load settlement curve for pile. From there, once you have the load settlement uh, curve for the pile, from there you can calculate the stiffness. If you don't have the load settlement curve, then you can approximately calculate the spring stiffness of pile by knowing the capacity of your pile, and then using the approach jugaad given in IS 2911 part 4, that is the testing provision. So you can use that provision to then find out the pile spring stiffness. So either you get it from the load settlement curve. Load settlement curve will look something like this. So this slope will give you the spring stiffness of pile. If not, then let's say you have the capacity of pile in compression. Now usually the capacity of the pile in compression is 2/3 of the total capacity at which 12 mm settlement takes place. So what you do some reverse working. So let's say capacity of pile has been given as 10 tons. Now what is this 10 tons? This is 2/3 of the load at which 12 mm settlement took place. So you try and calculate this P. How will you do it? So you do 3 upon 2 into 10 tons. This is your P. At this 12 mm settlement has taken place. So you do 3 by 2 into 10 tons upon 12 mm settlement. This will give you a K value. But this is a jugaad. It's not a very, uh, I would say, not a very appropriate approach. But then, in absence of any data, you could stick to this technique, or you take it from load settlement curve. Then his next question is how to know its influence area. I'm not sure what he means by influence area. Maybe he's asking influence area of pile. So that is a tricky question to answer because it depends on the Bosinisk's pressure bulb theory, that what is the influence area of pile. Therefore, what we do is generally whenever we provide piles, we provide some minimum spacing between the piles. So for example, if you have an underreamed pile, we provide 5 times the pile dia as the minimum spacing between two piles. If we have an end bearing pile, usually we try to go for 2.5 to 3 times the dia as the center to center spacing between the piles. So in order to avoid uh, two piles which are quite close by from influencing each other, we try and maintain some minimum distance between them. Okay, all right. So this was his question. Now let's see what other questions we have. So next question is from engineer Vijay Makwana. He is joining us from Ahmedabad. And what is he asking? He is saying, what if our shear wall takes more than 70% load? Then what do we need to do in ETABS? Because as per 1893, the limitation is 70%. I don't know where this limitation is. I think he's talking about some dual system. Please put your query in more detail. I am unable to understand it properly. Mr. Harish Acharya, engineer Harish Acharya from Bangalore, he is saying he is an undergraduate or a postgraduate student. What is the maximum percentage of reinforcement in beam when it will behave as under reinforced section in single and double reinforced section? See, it depends on what moment you have in your beam. What is the analysis moment, to what moment your beam is subjected to, and then what is the limiting moment. So suppose whatever reinforcement was required to have a balanced section for the given moment, suppose you do not provide that much reinforcement or you provide more than that reinforcement, then we decide whether it is under reinforced or over reinforced. But your question right now is not a very appropriate question right now, because just by having a reinforcement provided is not enough. We need to understand how much moment, that analysis moment, that beam is subjected to. Okay, so your question needs more improvement. Okay, then there are few questions from engineer Mansimran Singh. He is joining us from Ludhiana and he is a working professional slash independent consultant. So he has a few queries. What I'll do is I'll just copy them and maybe we'll try to answer it over here. Just a minute. Yes, let me just share my screen. Okay, so his question, first question is Mansimran Singh is asking, he's joining us from Ludhiana. What is he saying? Do purlins and girts provide a complete lateral restraint? It depends. if they are able to take 2.5% of the load in compression flange. So whatever is the axial load in compression flange, if your purlin or girth is able to take 2.5% of it in compression, that means the purlin or girth has to be checked in compression for the 2.5% of compression flange load. If it is able to take, then purlins and girths we can say that they provide lateral restraint, otherwise not. Also, just providing parallel purlins and girths may not be enough. We will have to add bracings also. We will have to add relative bracings also. Just providing parallel purlins and girths will not be enough. X bracings or relative point bracings are required. Then only we can say that sufficient or proper lateral restraint is being provided. Okay. Uh, yeah. So if you are providing flange braces, let's say the same rule has to be, you have to check whether the flange brace, let's say this is my rafter and there's a purlin going on top. I usually what we do is that we provide a flange brace like this to connect the bottom flange. The same rule for flange bracing also, whether or not it is sufficient, apply this principle 2.5% rule. Okay. His next question is, in PB from one gable end to another gable end, do we need to provide axial struts at specific location? Yeah, so usually we may like to have tie runners or X bracings. So suppose this is my, I'm showing you frames in plan. Let's say these are my PB frames in plan view. Just a minute. Just hold on. Yeah, so let's say this is my gable frame, and okay, so this was my starting gable frame and this is my ending gable frame end. So his question is, do we provide some axial struts? Yeah, so see, most of the times these PB people, they assume that there are enough purlins and then we provide sufficient lateral braces, typically at the gable ends and then somewhere in between also. So these are enough to take care of the loads that are coming in this direction. So most of the times you will not see any axial strut being provided separately. Uh, but yeah, I think it's a good practice mainly in truss-like systems when you don't have rafters. For bottom chords, we do provide these axial struts. But because for your rafters, you have the bottom chord and top chord both tied with purlins through flange braces or otherwise. So many of the times these PEB people don't provide anything. But yeah, I do agree that providing these axial struts or what we call as tie runners is a good practice, but not adopted so much by the PEB industry. They are mainly relying on these flange bracings that they provide. Okay. Do purlins attract axial forces? Yes, they may do so. But then, as I just told you, that we are providing these X bracings for the load transfer in this direction. For lateral load transfer in this direction, we usually provide X bracings and assume that the lateral forces will be transferred from these X bracings to rafter. So technically, in most of the calculations, we don't assume that purlins are going to take axial loads as such, axial compressions as such. Okay. Then his RCC design query is mostly the capacity shear according to 13920 results in a magnified shear force reinforcement, sometimes due to short span or sometimes due to, yeah. How can we get over this problem? No, you cannot get over this problem because code has made it problematic. When we check the this sort of capacity shear, code has made it problematic, especially because of the fact that we are supposed to take VC also 0. So when we are supposed to take VC also 0, then it becomes quite difficult to have such a lot of VS, because then all of the VU has to be taken by VS. There is no VC. So yes, it does cause a lot of heavy shear reinforcement. There is no solution to this problem. This problem has been uh, because of the codal provisions, so no solution. In ductile detailing, according to this, do we need to provide shear reinforcement according to capacity design at only supports? No, in the middle also, because see, as per the code, this is the total shear for which you need to design your beams. Now, at the middle, what will happen? This gravity shear component will go down, but then this shear due to the probable moment carrying capacity, this remains the same throughout the length of the beam. Okay, gravity shear value goes down, but this shear based on probable moment capacity remains the same. So in the middle also you have to provide the same. I mean, you have to do the calculations in a similar manner for midspan also. Only thing is that their values will go down because gravity shear reduces. Okay, good. So this was his question. Now there was one question which we had received on email, and that was, let me just open. Yeah. So I'll just take two email questions. So Mr. Umesh Naware, he had asked this question. I'll just copy it. He is from, I don't know, he has not written. Which city are you from? Pune. Okay, he is online also. So in one of his projects, he has an existing premix floor. Pune. Okay, he's from Pune. I need to place a platform on which Hilti or any other chemical anchor. My question is how to find premix is sufficient to take a load of pull out. How can I find concrete trimix can take such load? Any other solution? I also shared mail today with trimix details and reactions. Okay. So he has shared this reaction image. So in his case, the client does not want to provide a foundation and a pedestal for the flooring, and the client wants to have the flooring, sorry, have the, sorry, sir, I'll just repeat. Okay, so this is the floor, premix floor. Premix is nothing but a process where we what we do, we there's a mechanized process where the concreting is happening, and we are taking out the extra water from the cement concrete mix, and then on the top we also add some floor hardener. Okay, so that is usually called as a premix floor, generally used in industrial floorings. So now on this floor, they want to provide a pedestal. They want to provide or support a column which is having these types of reactions. So now what is this question? His question is that he needs to place this platform. Uh, we design. Okay, so in this case, because the concrete is existing, you will have to go for an anchor fastener, and because it is an existing floor, to have a good bonding, usually we may go for a chemical anchor fastener. That's where these companies, different companies like Hilti or Fosrock, no, not Fosrock, Hilti, and which are the other companies? I'm not able to recall. Hilti has such a large market presence that I'm not able to recall these other chemical anchor companies. Anyway, so his question is how to find out whether the trimix is sufficient to take this load or pull out. So see, for this anchorings, anchors, chemical or otherwise, you can refer to ACI 318. Although I also don't have a working knowledge about it. But if you refer to ACI 318, there are some good. There is a complete chapter given in ACI 318, chapter J or K, I think, where you will find these processes for finding out the uh, failures of these anchors, especially the cone formation failure or the failure in pull out, that is the cone formation, or failure in lateral loads. This they tell you the capacities for it. But let's say if you are working with a company like this, then these people, in fact, you can approach this. Let's say you approach a Hilti engineer, and then they have developed their in-house software, so you can give this problem to them and tell them that I have such and such issue, such and such reaction, whether or not a chemical anchor is suitable for this application. So these people will themselves give you some design calculations based on their product, and then you will be able to take a decision. So I also don't have a working knowledge of the calculations that go behind it, but then these people do such or provide such services. But in your condition, in your case, the issue is something different, because if you see, the column has a very heavy axial load, isn't it? So your column is having a 322 kilonewton of axial compression. So when it's case of axial compression, you need to understand that chemical anchors beyond a point will not help you. What will help you is the flexural strength of this trimix floor, and even more than that, what is going to help you is the stiffness that this filled up soil is going to offer. Okay. So if my soil, the soil fill that I have done, if it's not strong enough, then no amount of uh, premix floor strength will help you, or it is going to help you. Okay. So because you have a heavy compression load in your column, instead of relying on these chemical anchors, you should be more careful that what is the strength and stiffness that is going to be offered by this build up soil. Now since your this problem that you are facing, you have an existing premix floor, so you really don't know what is the condition of this compacted soil below, isn't it? You cannot be assured of it. So in my opinion, what is better in this case is to break this floor and go for a pedestal footing thing, because this load is not small, this is substantial load. Okay. So my suggestion will be, because you have heavy compression load and because you don't know what sort of filling has been provided, and if filling is not good enough, no amount of trimming strength, floor strength is going to help you. Your floor will crack or it will break, and if the filling is not strong, it will show you problems. So go for a pedestal footing type of thing instead of just going anchoring to the floor. That is my suggestion in this case. And for chemical anchors, if you want more information, you can get in touch with these applicator companies, they will provide you the necessary capacity calculations. Okay. All right. Then we have question from Ketan Mahajan. He is a working professional and he is joining us from Jalgaon. So he has sent a couple of images. Let me just. So he is asking two questions. One was how to do these kinds of flared up columns. How to model these types of flared columns. This was one of his questions. So in this case, there are two approaches that you can adopt. Number one is that you model it as a shell element, and in the shell element, what you do is in elevation, I'm showing you. So you model a shell like this in elevation. Okay. So the thickness of this shell will be this dimension, and then whatever is the flaring up happening, this will be modeled like this. Okay. So you model a shell element. This is shell element in elevation that I'm showing you. It will look like this in elevation. So in ETABS, you model a shell element like this, and then the profile of this flared column can be provided in this manner. So this X is varying, thickness is same. So the shell thickness you give it as from the property definition, and this layered geometry you actually give by varying this dimension. This can be one of the ways. Other way can be that you model a line element, and then there are options to give a tapered property in ETABS. So you give it a tapered section property in ETABS. That can be another way. Third way can be that you model this column as a line element. You break down, let's say you add nodes, you divide it in nodes, and then to each section you provide a rectangular section like this, but with dimensions that are increasing so as to get the flared geometry. Is that clear? So these multiple approaches you can adopt to model such kind of a thing. And then analysis will happen in a regular manner because you have modeled the stiffness and you have modeled the geometry. So analysis will happen in a usual manner. Yeah. His next question is he had seen this photo and he is asking what's happening over here. So if you if you see these columns are going beyond the slab edge, I really don't know what's happening over here. So if you see these columns are projecting beyond the slab edge, so I'm not sure what's happening. I really have no clue what is being done over here. Okay. Yeah. So these were questions asked by Mr. Ketan Mahajan, and then we have question asked by Engineer Devlin. He's from Oman. He's a working professional, and he has this problem where he's saying that he's facing this issue. Yeah. So what is his problem? He's designing a shed. His main frames are okay, but then his end frames are requiring huge sections. When I delete the tension only property from bracings, the sections are getting passed. But when I provide see what is happening is that your gable frames, and then he has shared a stat model also. So what I will do is, let me see if I can share the stat model on the screen, or I'll just take a screenshot of it. Wait, what I'll do? I'll just take a screenshot of this STAD model and perhaps paste it over here. I think this STAD model is visible now. So what problem he is facing on these gable frames? He is getting unusually high utilization ratios when he provides tension only bracings over here. So see what is the problem, what's happening? These gable ends have to take wind in this direction. So what happen in such cases that these gable frames are then subjected to out of plane movements, and these out of plane movements can come from these gable columns. So one thing that you can do is, I think you have already done it. Just a minute. Okay, top release you have already provided. Top release you have already provided. One another thing you can do is, so he's saying when he provides tension only bracings, uh, what is going to happen, that all these bracings will not take tension. I mean, none of them is taking any tension. So this gable end will experience lot of out of plane movement. That's why you will see a high utilization ratio. Now when he removes the tension only bracing criteria, then the bracings, because they provide uh, strength and stiffness, so his utilization ratio also becomes normalized. So what is the solution he is saying? So what you can do is, instead of providing tension bracings to all, maybe you can try to provide, or maybe you can run a non-linear analysis where it will take uh, compression only for lateral loads and no compression for gravity loads, and then you can assign that these members, let's say, will take compression, okay, for lateral loads, and then these bracings will not be effective at that time. Maybe you can do such a thing, or maybe what you can do is just take this out, just take a gable frame out. See, this is the problem that you will face with 3D modeling. So just take this gable frame out, provide horizontal restraints over here. Don't worry about the wind forces that are coming from this direction on gable, and just independently design this gable frame for the gravity loads and wind in this direction. Don't design this gable when you are making a separate model for out of plane wind forces. Just design it for the in plane wind and the gravity forces, and just ensure that stiff enough bracings have been provided. So that can be one of the options. Okay. Okay. So these were the questions that have been asked on the email and on the Google form. Now let's see what are the some of the questions asked on the live chat. So Engineer Nagesh Yadav is asking, can you explain the effective length factor if truss is modeled in StatPro? It will be a long discussion, so if you have any specific question on it, please ask. Vishal Patel is saying, can you please give some discounts on your courses? No, we do not have any. Unfortunately, we don't have any policy of offering course discounts. So I'm sorry for that. Engineer Dhruv Panchal is saying, I asked you about the resources to learn PEV structures. Can you name some books or documents from where I can learn about PEV and about structures of oil and gas? So for PEV, we have done some good courses. You can have a look at that. Other resources, as I have told you, this Zamil Steel Handbook is a very good resource. They have explained a lot of detailings and lot of systems that are adopted in PEV. So maybe you can go to this handbook. Maybe you can go through the MBMA code and just read about basics of structural steel design, especially for three plate sections, because in PEV mostly these three plate sections are being used. So read about the design and detailing for the three plate sections along with their connections. So I think this much should be enough. And then your usual basics about wind, gravity loads, etc. Okay. Okay. So I think that's all we have. We have answered all the questions on the email, and we have also answered all the questions in the Google form. So I guess that is it for this week. Thank you. And now we will see you next week at same time. Thank you. Oh, what about oil and gas? I don't know. As of now, I don't know. Uh, Maybe in future we'll bring some course on it. But as of now, I honestly have no idea. I mean, from where to read about it? Okay, thank you. Bye bye. So that is all we have for this week. Thank you, and we will see you next week now. Bye bye.